everyone, this is Captain Dave. This is my 1988 Island Packet 27 sailboat, which I recently converted to electric drive. I pulled that old stinky Yanmar diesel engine out and I actually put in a full electric drive system. I mostly sailed this boat up and down the east coast of Florida with my wife and kids. Usually just kind of day sailing and weekend trips, but we have sailed it all the way down to the Keys and all the way up to St. Augustine on some longer trips too. A lot of folks have asked me if I could give them some details, just kind of share some information on the conversion that I did and some of the what are some of the components that I used and what were some of the challenges. So I figured I'd throw together a quick little video to kind of go over some of that and hopefully it can help answer some of those questions.
Hey, morning everyone. Captain Dave here. Sailing vessel Gilbert Ivy, Island Packet 27. A lot of people had asked me if I could do a quick little overview of the electrical installation I did on this sailboat. This is a 1988 Island Packet 27. To the best of my knowledge, there aren't any electric Island Packets in the fleet, so I may be the first, but I don't know that firsthand. I don't know for sure. Anyway, so I thought I'd give a quick little overview here of what I did. I bought most of my components from Thunderstruck, as well as AliExpress for my battery system. And then I also made a lot of my own parts out of aluminum. I made my own battery. So I'm just gonna kind of walk through the system, show what some of these components are, and if anybody's interested in doing a similar conversion on their sailboat, I'd love to help you out and give you some free advice. Just shoot me a message. Just one quick disclaimer: I am an electromechanical engineer, so a lot of this electrical stuff I kind of, I designed this system, and I know the science well because I am an electrical engineer. I do this for a living on aerospace type systems, so I wouldn't recommend just willy-nilly starting to throw components together. If you have questions or things you're not sure about, please shoot me a message. I'd love to answer your questions, help you out, because I realized right away, as soon as I did the electric conversion, I realized right away that I'll never go back to diesel. It's just so great to pull in and out of the marina and not hear that diesel or not smell those nasty diesel fumes. It's just I don't know, it's just really nice. It's nice and smooth, and it's just a great feeling. So anyway, let's walk through the system. Okay, quick overview of the engine system here. Just want to kind of show the components of this kit. It's pretty easy install. Like I said, here's the main panel. So this is the main. This is like the old ignition switch, I guess, but it's just an electrical switch. I used some of the old holes. I think this was like my fuel. This was my fuel gauge here for that old stinky Yanmar, and this was the kill switch, right, to choke it out. And this was the main panel with the start button and everything. So I put this battery monitor in here to monitor my capacity. You can see I'm at 97%. I got a 280 amp hour battery with a 70 amp hour reserve. And then this is monitoring, just a quick little voltage monitor for my 12 volt system. I like to just keep that there. I needed something to fill the hole more than anything. I didn't want to try filling fiberglass, so I popped that guy in there. It fit perfect. So, and then this is just a little, rather than that old kill switch, I just put a couple of USBs in there so that I can keep my phones and devices charged, just for some extra outlets. Anyway, here's the motor system. I do have a kill switch in here. I put a main switch, even though I've got the key switch, I like to have a main kill as well. This is the motor right here. Let me back the camera up. This is the motor. It's a Motenergy 10 kilowatt from Thunderstruck. It is sitting on a mount system that I bought from Thunderstruck, and I fabricated some of my own components to just kind of hold it in place. This is the controller. It's a Sevcon Gen 4. This is the contact. On the back here is the heatsink. One thing that a lot of folks get wrong is the orientation of the heatsink. I see a lot of folks having these rotated 90 degrees. Unless you're gonna have a fan that's pointed right at this, blowing along those fins, you really wanna orient it like this, because the way heat sinks work obviously is just distributing the heat through a greater area. So if this is on its side, this heat wants to travel up and up and up and up and up and up. But if it's vertical like this, it can all move out as designed. So unless you're gonna put a fan on this, which you probably won't need, remember to orient it this way. I see a lot of folks get that wrong. The wiring's pretty simple. This hole goes through to my battery compartment, my 48 volt battery. I bring the negative to the switch. The power comes into the contact, it goes to the controller, which sends it out to the motor. And then of course there's a cable that comes out of the controller here, and I wire it up and through, and that goes up to my pedestal. A couple pulleys and a belt, nice and simple. For the motor mounts, I did put some rubber washers under here just to give it a little bit of vibration dampening, and that works pretty nice. And then I used just aluminum angle to you know, a piece of bent aluminum plate here to just give it some structure and hold it all in place. And it's worked out pretty well so far. I do bring the original ground to this because it still goes back out the same way it originally did, which is through this structure and through the bolts down through into the keel. Let me flip around and show the coupling. So flipping around here, this is just the other view. I just turned myself around 180 degrees. You see the bilge down there. This is the coupling. So this is the original shaft, and this shaft comes off of the motor mount system. Hope you can see that. This is the coupling. It's a little different than the coupling we had originally in the Island packet, but it's really nice because it's essentially two sprockets and they're coupled with chains. So that does allow for a little bit of misalignment. Not a lot, but you know, 1/16 of an inch, maybe a little bit more, and it'll still allow it to run true. Everything else is the same. It's got some little wood rough keys under there that kind of attach it to this so this can spin and bring it. And then it's got a couple of Allen keys, set screws, sorry, that you'll need an Allen key for. Highly recommend that you put some Loctite on those set screws. I've heard of people that have bought this same component and they have forgotten to do that. And through vibration, it's worked loose and it's actually come uncoupled while they're out on the water, which is probably not ideal.
Okay, so here's a quick overview of the components that I bought for this. I bought the Thunderstruck kit and gear reducer. I bought my own lithium iron phosphate cells to create my own battery. And I used the Overkill Solar 16S battery management system with that battery that I built. And I had to buy a bunch of angle and stuff, aluminum angle, aluminum plate, just to get the motor actually installed. Bought a couple of Panasonic SC330 solar panels. I bought these ones specifically because I wanted to have high wattage, but also high voltage panels. I didn't want to string together a bunch of 12-volt panels. So you're going to need 60 volts, and that's what these are. That will keep a 48-volt battery charged full. And then I also bought the Dakota Lithium 48-volt fast charger, which has been great. So I highly recommend Thunderstruck, Overkill Solar, and Dakota Lithium for their products. They're excellent. I also built a workbench out in my garage, and I put a couple of 2x4s, smaller 2x4s that you see horizontal on top there. Those were intended to kind of mimic the rails inside the engine bay on the Island packet to kind of mount it and just make sure I've got all of that figured out and the spacing right. So this workbench, you know, I spent a lot of time out here on this workbench kind of piecing everything together and making it work. So you can kind of see here, my components started arriving. Those were my 16S 3.2 volt cells. The motor, started kind of piecing all that together, taking measurements, and eventually kind of came up with a few different ways to actually combine all of those cells and run them in series to get the voltage that I needed. And then it was just a matter of kind of hooking everything up together and started running right away. It was really easy, but it was running without a load, so that was a little bit difficult. It would shake around a lot and stuff. I had to really bolt it down and get it secured really nice. Then it was time to lift the engine out, used the boom and some straps, some winching tie-down type straps. Got that hauled out right there in the slip, pulled it up. I had a couple guys help me. Got some muscle, some fellow sailors. They pulled that out and hauled it away for me. And then it was just time to kind of clean up the engine bay and get it ready for the electrical installation. So I measured the original stringers and mounting points inside the engine bay to just make sure I had the parts that I needed, the right lengths of aluminum angle, and then just kind of started placing the pieces into position and just kind of putting it all together. This took me probably about 2 weeks to get everything right and to get it to fit right before I could start running it and really making sure it worked well. That's mostly because I can only work weekends and evenings on this. Once I had the motor installed, I started measuring the old batteries and that whole area and figuring out how I would fit my 48-volt battery in there. So I pulled the old ones out and kind of cleaned the area up, started bringing the cells in. I actually pieced them together kind of 4 in a block and wired them together like that, and then just kind of framed them in with some just some lumber. I forget what sizes they were, just kind of put it all together, and it seemed to work pretty well. The last step to get it to work was to create a panel, replace the old panel with a switch to just kind of put the systems together so that the battery would be able to send power to the motor and control. Once I had that all working, I was, for all intents and purposes, up and running. And so I started looking at my charging system, measuring up my davit frame, and figuring out how I could put together something to hold the solar panels that I bought. I wanted something that would be, I could pivot and adjust based on my position and the sun and, what direction I'm heading. Figured I could squeeze an extra couple of hours of daylight out if I could give it that adjustment. So designed something up and had some parts built, and came out pretty good.
We're sailing back in. I got the sail up, but as you can see, it's luffing pretty good. There's not a lot of wind. So I'm mostly just motoring, and I wanted to just kind of show, right now I'm drawing about 8 or 9 amps, and I'm doing, I don't know if you can see that or not, but I'm doing just around a little under 3 knots right now. I can juice it up a little. Just want to show a little bit about the differences in speed versus amp draw. So now you can see I'm all the way up to about 26, 27 amps. And give it a minute to get to speed, but it's, it gives me maybe about another knot or so. So, the key can be being willing to go a lot slower. I mean, I can motor like this for quite a while, right? I've got 280 amp hours. So if I'm doing about, well, really I've got 350 with my reserve, but if I'm doing about 28 amps, that would give me, 10 hours at about this speed. A little bit less if I'm going faster, but just to kind of note. And of course, I don't know if you can hear the motor or not. There is a slight hum there, but it's very, very hard to hear. It's just very pleasant. But that weather is not, so I better head in.